Hello again. So let's talk about the next topic here, which is how do you partition a segment? First, what does that even mean? Well, to partition something means to break it up into multiple pieces. And so we've talked about the midpoint, which breaks things up into two pieces, and that's finding the average. The partition, a segment, this part of the notes talks about breaking it up into more pieces. So if we wanted to break it up into more than just two congruent pieces, but maybe 3 or 4 or 5 or 6, and more specifically, how do you find the point on the line that might be 3/5 away or 3/4 away or 7/8 away? And so we're looking at other fractions rather than just 1/2. And so first things first, a key piece about this is how do you multiply fractions? And so let's look at an example here. Let's go ahead and pick the color purple because, go Rams. Let's say we have the number 4 and we wanted 1/8 of 4. Well, if we're going to multiply these fractions together, wait, you're saying there's only one fraction? Alas, we have two fractions because any whole number is divided by 1. And when you multiply fractions, you multiply straight across. You just multiply the tops and the bottoms together. 4 times 1 is 4. 1 times 8 is 8. And when you're dividing, it's the same thing as multiplying by a fraction. 4 times 1/8 is the same thing as 4 divided by 8. And 4 divided by 8 is 1/2. So let's apply this to a grander scale. Let's apply this to a line and see how it all pans out here, right? So basically, what we're looking at is our diagram once again. So I'll go ahead and draw the vertical line, draw the horizontal line. And so let's say we want to partition a segment. Let's say we want points M to be -3, -2, and point K to be 9, 6. And let's go ahead and add an extra layer here. Let's say we want, so let's find the point 1/4 from M to K. First, the language here is very important because 1/4 from M means that we're starting at M and then going 1/4 the way to K. So first, we'll need to know what that distance is, and then we'll be able to look at our X and our Y parts separately and find our point that way. First, let's graph it. M, -3. 1, 2, 3, 4, 5. So -3, -2. 1, 2, 3, 4, 5. So -5, -5, -3, -2. That's our point M. You may notice that in this example, I'm not writing the points themselves, but I'm writing the letters just because it's a little bit easier and a little bit cleaner and a little bit easier to follow. And so you're more than welcome to name your points anything you want if they're not already named. And as long as you're clearly communicating that, people will be able to follow along and work along with you. K is 9, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, 1 off. So I'll go ahead and extend my line. 9 and then up 6. 1, 2, 3, 4, 5, 6. So over 9, up 6. There's our point K. And here is our line. Now, we want 1/4 of the way from each of these points. So let's go ahead and first identify what the full distance is. Now, I'm not finding the distance of the full line here. Why? Because we want to take advantage of how we name points and how we label points. We label points with an X component, and we label points with a Y component. So let's take advantage of that. Look at our two elements of this separately, and by combining and working with both of those, we'll be able to find our point 1/4 of the way. So to find the distance between m and k for x means we're finding the difference between m and k. If we're finding the difference, it means subtraction. And so m, looking at this whole piece where we're at -3, and k, where we're looking at 9, just looking at our x values, to find that total distance, we want to subtract 9 from -3. And whenever we subtract a negative, we have a positive. So this total distance is 12. Same thing for k. We want to go ahead and find out where we're starting and where we're ending. So our values of k to m on our y aspect, our m is at -2 for our y aspect. Our k is at +6 for our y aspect. And so to find the total distance, we want to do 6 minus -2. And so what we're looking at for our y aspect there is 8. Now, you guys may be thinking, hold up, what if we did the subtraction in the other order? And you absolutely can. You might have written -2 minus 6, but I want to pay close attention here to what I've been saying, which is distance. Distance doesn't care about direction. It's always positive. And even though we want to go from m to k, we're not there yet for the problem. We just want to know what the distance is first, and then we can care about the direction second. And so if you do -2 minus 6, you want to put them in absolute values. You want to talk about the distance there first, and then we can talk about the direction. So, ladies and gentlemen, we wanted 1/4 of all this. So what we have right now is we have 12 for our distance of x. So what's 1/4 of 12? So what's 1/4 times 12? Well, 1/4 times 12 is 3. And well, what's 1/4 of 8? So what's 1/4 times 8? 2. So we want to look for the point that's 3 away from m on our x and 2 away from m on our y. And so let's count that. From m, we can go 1, 2, 3 away. That's the quarter distance we're looking for. And we want to find a point that's 2 up. Ladies and gentlemen, we found our point. The point 1/4 of the way from m is the point 0, 0. Ladies and gentlemen, this series of triangles may remind you of slope. If so, that's great, because when we talk about the formula for this, the formula does look a little bit like slope, because the slope is about the rise over the run. It's about the change, and change means difference, which is subtraction. And so when you look at these triangles and you see the 12 and the 8, the connection to slope here is that it's all about subtraction. So if you want to find the point 1/4 of the way from m to k, you're going to do some subtraction and then some multiplication. So let's show that in application here for just the numbers. You're always welcome to draw a diagram. You're always welcome to use a picture, but here's the math that's behind it. So the math that's behind it, I'm actually going to write you a list of 3 steps. First, find the difference. And you're finding the difference of your x values and y values separately. And so essentially you're taking your x1 minus your x2 and your y1 minus your y2. Second, multiply those differences by your fraction. In a partitioning problem, you'll always have a fraction because you're always looking at the part of the line. And so after you take your differences, multiply those differences by the fraction. And so then the last step, 3, is add them to your point. And you want to focus on the point that you're starting from. In this last example we did, we were starting with m because it's from m. And so we added it to m to get to our new spot. So I hope that helps. I hope that provides some feedback. Don't hesitate to ask lots of questions, and I'll be glad to help. Thank you.